Here we have question 9. Gertie writes down the following sequence, which repeats every 3 terms. 364, 364, 364. Write down the 12th term. Well, there's 364, we have 9. 364 again, so the 12th would be 4. The 100th term, well, if they're going in threes, the first 33 threes in a row will be 364, and then the next one will be 3, so that's the 100th, 3. And describe how to find the nth term of the sequence, where n is an element of natural numbers, without listing all the terms from the first to the nth. So a little bit tricky if you're not really good at understanding the question in words. So let's have a look at this one. So what they're looking for here is division. So the nth term, say the first, the second, the third, the fourth, the fifth, the sixth terms of the sequence. So we know that the sequence repeats every 3, 3, 6, 4. So really what they're asking is, how do you get these ones here, the 4th, 5th and 6th term? Well, if we divide the 4th term by 3, the remainder is 1. And when the remainder is 1, it's when we got the first term, remainder of 1. When the remainder is 2, so we divide the 5, the 5th term by 3, the remainder will be 2. This is what they're looking for, division of 3 and remainder of 2 in this question. The remainder 2, we're going to have the second term. So this one here, second, a remainder of 2, I might write remainder here. Remainder. And if we divide 6 by 3, we get 2, no remainder. The remainder is equal to 0. We're going to get the third term of the sequence. So the remainder is 1, it's the first term, 2, it's the second term, and 0, it's the third term. The next part of this question is worth 5 marks for C and D together. You can see why it looks quite long, but it's quite easy. Gertie made up this sequence by picking 3 as the first term, and then using this rule. If the term is odd, which 3 is, you can see this information is written here. We multiply it by 2 to get the next term, which will be 6. And if the term is even, we add 2 and then half our answer to get the next term. 6 plus 2 is 8 divided by 2. 8 divided by 2 is 4, which is where the 4 comes from. And now we're told we have a new sequence with 8 as the first number and apply the same rule to this sequence. So if the term is even, we add 2, so 8 plus 2. And then we half it. 8 plus 2 is 10, divided by 2 is 5. 5 is the next number. If the term is odd, we multiply it by 2 to get the next term. 5 is odd, 5 by 2 is 10. 10 will be the next one, which is even. What do we do with even ones? We add 2 and divide by 2. 12 over 2 is 6. 6 is also even. So we're going to add 2 and divide by 2. 8 over 2 is 4. So a bit of math involved, but nice and easy. So we just asked for the second term in part 1 here. We've worked out, actually we're asked to work out the next 4, and they just give the start of the second term. There's what they've done. Now Ahmed takes 2 as his first term and makes the sequence using the same rule. What's unusual about Ahmed's sequence? It might be helpful to work out some of the terms. Okay, let's do it here. If 2 is the first term, it's even. We're going to add 2 and divide by 2. 4 divided by 2 is 2. So the same number again. So we're going to get 2 plus 2 over 2, which again is equal to 2. So adding 2 and dividing by 2 is just 2 all the way. 2 all the way. That's what's unusual about his. If you start with 2, if you add 2 and divide by 2, you'll always get back to 2. That's part C and D. You can see why they're only worth 5 marks. E and F are worth 10. So E and F, 10 marks together. In another sequence using the same rule, the second term is 86. Work out two different values that the first term could have been. Well, if we're going backwards, we're dividing something by 2, and the answer is equal to 86. So going in the opposite direction, we'd multiply two 86s, are 160 and 12, which are 172. And then going backwards, we were adding 2, so we'd have to take away 2. So 170 looks like it's the first term. I double check it. If the term is even, we add 2. Divide by 2. 172 over 2 is equal to 86. So 170 definitely works. And of course the first term could have been odd, which in which case we'd be multiplying by 2, so we just divide by 2. 86 divided by 2 would be 43. Part F, a different sequence following the same rule starts with k, which is odd. So the next one's going to be 2k. And 2 times any number is even. Just double check that. 2 times 3 is 6. 2 times 4 is 8. So 2 times any number is even because 2 is a factor of it. So even, what do we do to the even ones? We say 2k, we add 2 and divide by 2. And 2k plus 2 divided by 2 will be equal to k plus 1. K plus 1, is this even or odd? Well, k we're told is odd, so k plus 1 would have to be even. So k is odd, if we add 1 to it, we get 4. So I pick any odd number and add 1, the next one will be even. So this is even. I'll just write any under this one too. This is even, this is odd. So even, what do we do? With even numbers, it's k plus 1. We're going to add 2 and divide by 2, which is equal to k plus 3 over 2. K plus 3 over 2, fit it into this box here. So you can see rough work all around the corners. That's what you should do in the exam. Don't be afraid to do the rough work down the sides, and then add them in as you go, your answers nice and neat and tidy. Question 10 is just graphing two functions. We have an inverted quadratic minus x squared, and we have an exponential. And we're given a domain of minus 2 to plus 2. So let's set up the calculator to do these. Minus 2, minus 1, 0, 1 and 2 are the numbers we're putting into the function. You're going to set up your calculator and then just go back and change, or whatever way you find quick enough. Something like 10 times x minus 2 we'll put in first, minus 4 times x squared minus 2 squared. Putting this into your calculator, you're going to get 20 plus 16, which is 36. Putting minus 1 in, I'm not going to write them all out, but putting minus 1 in, you'll get 14. Putting 0 in, you'll obviously get 0. Putting 1 in, you're going to get 10 minus 4, 6. That's a 0. And putting 2 in, you're going to get 20 minus 16, which is 4. So graphing this, minus 236, approximately there. Minus 114, just below 15. 0, 0. 1, 6. Just above 5. And 2, 4. What I've done deliberately, because all you guys do it all the time. So what have I done here that's hopefully going to make you remember not to make a mistake? So it looks like I have a curve here, but these 2 points look off. So these 2 points should be down here, shouldn't they, in the negative section? So you can see here the first one I've left it here should be minus 20, minus 16, minus 36, and minus 14. So just be really careful with these. Minus 36 will be approximately here. And minus 1, minus 14, approximately here. So I just wanted to highlight that mistake that you can make. Don't worry about the points on the graph. Just leave them up there. And make sure that you have a quadratic N shape for the minus, U shape for the positive. Again, y equals 3 to the power of x. We're putting in 5 values. Minus 2, minus 1, 0, 1 and 2. I won't make any mistakes this time. Putting minus 2 in, 3 to the power minus 2 is 1 over 9. I'll just write 1 over 9 actually, 0.111. 3 to the power minus 1 is 1 over 3. 3 to the power 0 is equal to 1. 3 to the power 1 is equal to 3. 3 to the power 2 is equal to 9. So minus 2 and a tiny bit above 0. Minus 1 and a tiny bit above 0, but a little bit higher. 0, 1, which will always be on this exponential. 1, 3 and 2, 9. Like this. You know the shape of these goes up like this. So there were 10 marks for each of these graphs, so 20 in all, 20 for graphing. Nice easy marks when you know how to do it. 10 minutes given. You can see it doesn't take that long. You're going to take a little bit longer in the exam. Question 11 is worth 10 marks. The way I would have taught you in class. 3 times 3x plus 5. You can do these much quicker if you want. Plus 2 times x minus 4. But we'd always just lay it out like this. Do a common denominator, not common, just the denominator. 2 by 3 equals 16. So it's just the layout of it. So now we can multiply out the brackets. 9x plus 15 plus 2x minus 8. And we can skip a little stage here. We write equals 16, but we're going to multiply the 16 by this 2 by 3, 6 to get 96. So 11x, 9x and 2x, if you want to underline them, equals, maybe just take one extra step, 96 minus 15 plus 8. So 11x is equal to 81 plus 8, which is 89. X is equal to 89 over 11. It'd be awful to be asked to verify that. You just put it back in for X and then put it into your calculator. But you may, when you get a question like this, doesn't work out even, you might think, oh, it should have been 88 over 11, which I have gone back and checked, but the answer is definitely 89 over 11. So maybe just double check your answers with these and move on really quickly. But there was a little bit of a clue here in the question. M over n, and both of them are natural numbers, so kind of clues to help you along the way. Question 12. Factorize difference of two squares here you need to identify. Same thing in both brackets. A by a gives a squared. 4n by 4n gives 16n squared. One's a plus, one's a minus. Doesn't matter the order. There were 5 for A. There were 15 for B. So mastering quadratics is the key. One of the factors of 8x squared plus 45x minus 18 is x plus 6. So we've done loads of these in class. X plus 6 by something gives what's above. Has to be 8x to give the 8x squared. It has to be minus 3 to give the minus 18. And then we just multiply it out to check. 8x squared minus 3x plus 48x minus 18. You just go like this. We can see that gives us plus 45, so then we know we're correct. Excellent stuff. We move on to the next part. Write down one quadratic expression in x other than this one that we have above that has x plus 6 as a factor. And it says give your answer in this form, and a, b and c are real numbers, just to confuse you. So all they're looking for 15 marks is to factorize this. You can see the test was quite difficult. I think in 2019 they made this one of the easy ones. So x plus 6 by any other factor. So you can pick anything. I'm going to pick 2x minus 3. And I'm going to write my expression. 2x squared minus 3x plus 12x minus 18. It's going to give me 2x squared plus 9x minus 18, which is another quadratic expression that has x plus 6 as a factor. To balance out the easy 20 marks so far in this question, if you didn't know this, and if you don't use the box method, I think you're crazy, but show that 2y plus 3 is a factor of this cubic. It's just long division box method. Set up your box. When you practice 10 of these, you'll never forget 2y cubed. First term and last term in these boxes. And your factor 2y and plus 3 on the outside. So this divides in with no remainder. It's a factor. 2y into 2y cubed is just y squared. And the plus 3 by this y squared is 3y squared. And I don't need to explain to you that these two boxes give me the y squareds. We need -9 of them. We have plus 3, so we're missing a -12y squared. And then 2y into 12y squared is -6y. And -6y with plus 3 is -18y. How many y's do we want? -28, so we're missing 10 of them. And then we say 2y into -10y is -5. And -3 by -5 is -15. So excellent. Question 13 has Frida starting an exercise program. She wants to increase her power output, which is P. Here we have P, and we have variables here, W and H. So W is Frida's weight in kilos, and H is the height in meters that she can jump. Work out the value of P. So this is a substitution question. W is 70, H is 0.65. Now, if you get frustrated at the beginning of the test, there's always nice easy questions at the end. 36, W is 70. This is just calculator use. Plus 62 times H, 0.65. Plus 1800. You type it into your calculator. You write down what you get off to the side. The first time I do it, I'm getting 4360.3, 4360.3, and then I clear my calculator and I do it again. And I get the same answer the second time. If I don't, I jot down the next answer. It's easy to make a mistake. You might leave out a bracket or a decimal or something. But this is the power, 4360.3. For part A and B, there was 10 marks in total. After 1 week, Frida's power output has increased by 8. So what's that now? Her new power output is 4368.3. Her weight has not changed. Work out the new value of H. So H is the only unknown. So we have power is equal to, so we have this 4368.3 is equal to 36 times her weight. 36 times her weight has not changed, 70. The unknown is within the 62H, the height she can jump, plus 1800. So we leave the 62H alone, and we take away these from the left hand side. We're going to get 62H is equal to 48.3. Just double check that on the calculator again twice as well. So H is equal to 0.779 on my calculator. I always go back up and check when we've got decimals, 2 decimals. So 0.78, and it was 0.65 before, so quite a big increase there. Let's look at part C. We're given this graph below. It shows the value of P for different heights when W is 70. The graph cuts the y-axis when P is 4320. Draw a graph to show the values of P for different heights when W is equal to 80. Using the same axes, scales, domain, huge amount of words here. State on your diagram the value of P where your graph cuts the y-axis. Note, the axis with P does not start at 0. So if we have W of 80, so values, draw a graph to show the values. I'm going to read it a second time. Draw a graph to show the values of P for different heights H when W is equal to 80. Well, when W is equal to 70, it's down here. What about when W is equal to 80? So let's write out the formula. Power is equal to 36 times the weight, and we're looking at 80 plus 62H plus 1800. So the power output of this 80 kilo person If I add 1836 times 80, I get 4680 plus 62 times h. So slightly bigger than 4320. So what they're looking for here is a parallel line, which that is supposed to be, and the number 4680 here, and W equal to 80 kilograms. Quite a tricky one, and that was only worth 5 marks in 2019. Frida has this problem now. She finds a second formula for power output, and she sets the two formulas equal. This guy here, big long list. What unknowns have we got? W, H, F. Don't get confused by all these. W, H, no F. So write H in terms of W and F, and they're telling you here H equals. So we want H on its own. I have 80 minus 62, so I'll bring them to the left. 80H minus 62H equals, we already have 36W over there. We're bringing across 60, so minus 60W. We're bringing across the minus 15F, so plus 15F. We're bringing across minus 1300, and we already had this plus 1800, so that's plus 1300 plus 1800. So we've 18H equals, what have we got there, 24W minus 24W plus 15F plus 3100. So H would have to be all of this right hand side divided by 18. All divided by 18. So they're really just testing your simplification skills here. And that's the answer to that question. The last question in 2019, question 14, A was worth 10, B was worth 5. Given the first three terms of a sequence, 6x minus 3, x squared minus 2x, and 4x squared plus 3x. We're told to fill in the following table to write each of the first differences in its simplest form in terms of x. So what's the difference? So it's term 2 minus term 1 is the difference. If you imagine we had a sequence 2, 6, 10, if it was linear, the difference between the first two is 4. Where does that come from? 6 minus 2, T2 minus T1. So you can even do a little bit of rough work here just to remind yourself what it is. And it sets it up here for you. T2 minus T1. X squared minus 2x minus 6x, and the key to this one is just the minus and the minus plus 3. So we're going to have x squared minus 8x plus 3 is the difference between the first two. Term 3 minus term 2 is 4x squared plus 3x minus x squared plus 2x. We can do that in one step. So this one will change signs with the minus in front. So we're going to get 3x squared plus 5x as the difference. Show that if the terms form a linear sequence, so the differences have to be the same as the key to this one. This is the key knowledge, same diff, same difference. Show this 2x squared plus 13x minus 3 is true. So these two things would have to be equal. So I'm just going to write this here. You'd have it in the box below. This will be equal to x squared minus 8x plus 3. So 2x squared plus 5x plus 8x minus 3 would be equal to nothing left over there. So 2x squared plus 13x minus 3 equals 0. So for those two parts, 15, and then for part C, the quadratic formula to solve this guy. Doesn't tell you, just says decimal places. We'll see that now. So the quadratic formula, let's see how to set this up. And it just says 3 decimal places. That's the key to the quadratic formula. Minus b, or the minus b formula as you all call it, plus or minus the square root of b squared minus 4ac all over 2a. It should roll off the tongue. You should not need the formula booklet. I have told you repeatedly, write down your a, b and c. A is equal to 2, b is plus 13, and c is minus 3. And what I'd like you to do is write it like this: minus b is minus 13 plus the square root. You can put the minus in if you want, but you can't put that into your calculator at the same time. So plus the square root of 13 squared minus 4 by a, which is 2 by c, which is minus 3, all over 2a, and you'll see why we've left out the minus now, all over 2a, 2 times 2. Press equals, and then you write it out again with a minus, or you can just write plus and minus here and write the two answers. What they're giving me is 0.233 or 223, seeing double at this point after making your 3 videos today, and minus 6.723 is the negative solution. So x is equal to these two numbers. That concludes the 2019 paper in 3 parts. You had 2.5 hours. I think we got it done in just over an hour. Have fun attempting these questions. Practice, 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 and the exam in a couple of weeks' time will be so much easier.